Hey guys, welcome back to another video. So I was messing with Lua and a bunch of stuff in Rust, and now there's a very basic Lua API. Can't really do much with it yet, I'm still working with it. The next thing I want to do is set biomes you can define in Lua with the Biome Generator. We'll go over to that real quick. So if we go in the world, we get the Biome Generator. Let me just close this out. Let's see. I need to make this bigger so you guys can see. That should be good. And we'll go into full screen mode. There we go. Alright, so basically, this is the Biome Generator. So if you've ever worked with the voxel manipulator in Minetest, this probably would look kind of familiar to you, like Minetest at get block ID or get node ID. And so this is what it's doing, but this is doing it in the engine, which is going to be handed off to an API translation to get like the heat map of the current Y stack, so that biomes are not limited to being within a chunk. They're dynamic, and they will, I'll try to hold their data into a 2D map, so you can always get the biome information of the biome you're in. Let's say a biome could be literally just 1 by 1, which is just a single block stack from the top of the map to the bottom. So I think that's pretty nifty. So basically what's happening when you are genning the biome is this is getting the cache data. So if we go into the BCS, which the BCS stands for Block Component System. If we go into blocks, we go to the Block Component System. So the Block Component System is it's a hybrid implementation of a component system with object-oriented, but it leans more on the side of structure-oriented. I was messing with the Biome Generator so much, I got functional programming on my mind, but so this is more of like structural oriented versus object oriented, because you can't obviously just dump an ECS into a function. Like, you could have some way to control it, otherwise you just have vectors everywhere. And so now this, when you register a block, it pushes a new value in pieces into the component system, and then it will automatically map an ID to everything. If we go right here, you'll see that it says a built-in definition for ear. And what's happening with that is basically block 0 it's reserved for air, nothing. So it just automatically infers that definition 0 will always be air. So you don't even have to worry about that if you want to like wipe out the built-in mods and replace it with something else, but we'll get to that. So what's happening in get mapping is, get ID of is basically just enumerating the, it goes for the name vector, then it iterates it and enumerates it. Enumerate just puts a number value of the index into what it's finding. So then it becomes a tuple of the index and the value, which is a reference to the string. So now it's just checking if it equals the input, which in here is we're getting dirt, stone, and then this shouldn't ever be possible in the implementation, because I'm going to do a check against the biome registration, because I'm going to do the registration after I register all the blocks. or something. I'll have to check the registered biomes against the registered blocks to make sure that there is a block that you input. Like, let's say you do top layer has a depth of 3, and this is this block's called does not exist, and it scans through the existing block maps while it's still doing the Lua context, and it will try to find it out of that table. And if it can't find that value, I'm going to have it throw a Lua error and just tell you which biome is throwing the error and why it's throwing it. But I'm trying to do a lot of error handling as I'm building this, because it is extremely important to stomp out those errors now before you randomly have raw Lua just dumping in errors into your terminal, and you're just going to be like, oh my goodness, what is this? Let's see. So then it finds it, and that's the expect I just said. This should not be possible in the implementation. And then it will get the 0 index of that tuple, and because usize automatically, because it's a primitive, it automatically infers clone. I can just take it and say it's a U32 to get the index of it. So I think it's pretty neat. And yeah, it gets it as a U32 because that is the actual value that it's holding. Because usize is specific to iterating a position in a vector or an array. So yeah, it's just that's how it works. And then it returns it. And so that's why it's done once at the beginning of this. And this is not implemented yet, but this will be the Lua API implemented. So I need to remove these random testings because, I mean, it's not really, doesn't really have any use anymore. This is mainly for developing the implementation of the normal draw type, and we'll go look at the draw types right now. So the draw type is a numerator. So right now there's none for air-like or nothing. If you don't define one, it becomes normal, but this is specifically for nothing, basically. I don't think I actually implemented the air-like draw type yet, but I'll get there. Then you have block box, which you can define. It's literally just node box, but it's got a different implementation. So I'll show you that in a second. And yeah, that's the basic gist of what's happening. So I'll show you. I'll like glance over this, but this is so complex that I'm not sure I could really explain this in a video that's under 2 hours long. So I'm a really slow talker. Let's see. So basically, the Lua context, which is in the library, has a texture cache. And what happens when you register a block, this will automatically cache its texture with its mod. And so when it caches it, what it's storing is literally my mod. And 1 second, my key just broke. That was interesting, but it stores it like my mod, my block, and then it will go on, etc., etc., etc. And that's basically what this is iterating. It's pushing it into a vector of my mod, my block, and then it runs through all this. This is just decoding a bunch of stuff, and then this is actually doing the block registration. It's taking all the values you define in Lua, and then it's doing translations. I need to remove this, I forget to remove this, and then it will automatically numerate your string value. And Yeah, this is what I was talking about before, where you don't define anything, it's a normal draw type. Let's see. And obviously no errors have been hit yet because I didn't finish this part and I was too busy with the rest of it. And then I gotta do the block boxes tomorrow or maybe the next day. It's just I'm doing a lot of pre-calculations for it, so it's super extremely optimized when it gets implemented. So that's for down the line. When I get to the block boxes, I'll explain it. We go over to the default mod in main. This is how you define blocks. It's like dirt. So this is a test with everything defined manually. But if we go into the Lua functions, let's see, texture repeat. So like in mine tests where you define 6 textures for a node, you can just put in 1 and it'll just repeat it for all faces. So that's what the stone is doing. But I just thought it'd be helpful to like show this by itself. All right, let's see. So at block boxes, how it's going to be defined is the draw type will be block box. Then, so you have the block box, and for not only performance reasons, but clarity reasons and ease of being able to input code, I'm going to hold it as a flat Lua table. I keep trying to say array, but it's not an array in Lua. So that's box 1. So this is minimum X, minimum Y, minimum Z, maximum X, maximum Y, maximum Z. And then the next one, we'll just continue on like that. And let's just make it look even. And if you want a really inefficient draw type, you can have your block box be a full block. It just won't cull any of the faces, and if you try to render that out, you're just gonna be running it like 2 FPS, probably less. But that's how the block boxes will work. Like this is box 1, this is box 2. So if we wanted some stairs, so this is Y. Whoops, not 5.0, 0.5. So this is the bottom of the stair. We'll define this as stair bottom step. And then we'll say that this is 1.0. I don't know, this looks messed up because I just deleted a bunch of stuff, but that's how it is sometimes. And so this is stair step. And let's just say that the X will be the component. So this will have a stair that's shaped like this is the first step, and then this is the second step. So I think that's pretty nifty. It seems to allow you to do cleaner code, so you don't have to have these everywhere. And it just makes it so you can be like, oh, I want to type out this shape, so let me just do a couple of these, and bada bing bang boom, just type out some numbers. So I'm going to actually reset this because I was testing some float precision. It seems to have worked, but I just want to have some numbers to work with. Actually, we'll do that as 0.00001. And then we'll put this back. And then comment that out. Because what I'm going to show you guys now is it working. So let me just open a PowerShell. And so I noticed on Linux it's extremely fast. Like it's literally almost double the frame rate. It's kind of insane. I'm not sure what's up with Windows 11's kernel, but so you can see how it's defined. Unfortunately, there's no mining yet because I have to implement that. I'm not sure how I'm going to implement that. I'm going to try some new math where I draw a line and then iterate the line or something. I'm not really sure. But yeah, you can see that the stones there, I need to put in rotation. That's one of the things. These textures are actually sideways, and I need to fix that. But something extremely interesting. So let me go to my Mine Test Crafter project and grab out one of the textures, and I'll be right back. Okay, so I plopped in cobblestone. So we have stone, and let's just plop in cobblestone there. We'll call it cobble. Let's get the draw type of normal. And we'll just say, there you go. So that actually got processed, but because there is no biome generation, what we're going to actually have to do is we're going to have to go into here manually and rebuild the engine, because that's why I put in the Lua API. So the main focus is I want to try to unload as much like computational. I really don't know how to word this. Like, take the load off the Lua VM as much as possible and make it so that the engine is doing stuff lightning fast. So like, I have a plan for Lua entities like in Mine Test, but I have I'm going to do a component system in the world component system. So I'm going to have like a subsystem in there. And we're going to see how that goes. I'm going to have the ability to register Lua entities without like inertia systems and without, I don't know, color systems and stuff like that. It's just very complicated, and I have a lot of ideas, and I really can't explain it all in one video, so. Oh yeah, let's full screen this. So one of the things I also noticed in Linux is that it doesn't do that black screen when I go into full screen mode, so that's pretty cool. But you can see I've just defined this, and we can actually make this more extreme if we go out and we go into the Biome Generator. Let's see. Go on the noise multiplier. So this is actually being implemented in main. So let's see what I have set. So that's that. That's the noise multiplier. Ah, here it is. So we could turn this up to 100, literally. This might look really bad, but we're gonna find out. Okay, so it is actually capping out the terrain generation. So what we can do is lower the base height, and we'll go down to like 40 base height, and so that's allowing it to be 100. Actually, let's change that to like. Let's go. Here is 60 because it's 127 from 0, so 60 and 60. Then this should go all the way to the top and all the way to the bottom. Yeah, okay, so you have some extremely varied terrain here. I think that looks pretty neat. So this is, again, this is what I'm going to implement in the biome registration, is the amplification of the biome you're generating. Which, another thing is I'm able to just keep the chunk as one mesh per chunk. because Rust is so fast at iterating in release mode. I'm able to just dump meshes into OpenGL like instantly. So another thing is let's put this back to the way it was. Whoops. There we go. So we're going to implement a block with one of my debug textures. And we'll call this guy debuggy, I guess. Yeah, we'll go with that. And we'll make him debug 2, because debug 2 is actually twice as tall as the other blocks. But because I'm using texture packer from the Piston team, it will automatically automate this, and this is what it does somewhere in here. It's actually just kind of hard to work with the screen so big. So, I mean the scale is so big, but what it's doing here is when it dumps all those cache textures with their mod, is it will get the biggest width, the biggest height, and the number of textures. And then it does some basic math to make sure it always has enough room. And then it will configure the texture packer, which is the texture atlas creator. And then it will create one with that configuration. And let's see. So now it's taking all the defined textures and it is packing them into the texture atlas's skyline, which is, if you go to the texture packer creates page, it actually explains how it does it. I think it's really neat. It uses some extremely advanced math to cleanly implement that, especially with what I'm doing with zero padding. Let's see. And so one of the interesting things about this is I just convert the atlas. Let's see where I create the atlas. Actually, you know what? I can just click that. So this is what I do with the atlas, and I just export it as a dynamic image when it's done. And now I have a dynamic image which I can actually get the values of. And when it's all done, I can actually dump this into the mesh component system and basically give it, literally, that's what the toOwned function does, is it just gives it over to this function, and now this function or this structure has ownership of this piece of memory, which is pretty neat. One of the really helpful things with the dynamic image combined with the packer is I now have the packer, which holds the frames of the dynamic image, and it tells me where all the data is in the dynamic image. So if I go down to here, I can plop in the width and the atlas height of all of these values and pre-calculate the mapping of each individual block, basically, so it doesn't have to cross-reference the mapping into some other object. So that's how I avoided creating a secondary component system that holds the atlas stuff, basically. It's got a built-in component system. Let's see. Register block. That's where this is. It's an atlas map, and the atlas map is extremely simple. It's just F32s of min and max, and then you register it, and then you get it as a tuple, And I'll show you that too, why not? This video is already super long, so if you made it this far, good job. But what it does is it gets the frame of the texture from the face, and then it's dumped into this function, which utilizes all that data, and then does an automatic calculation, so it doesn't have to calculate that every single frame like what was happening in Java, which is extremely inefficient. But, you know, it is what it is. You learn. You live and you learn. So that gives you an atlas back. Then that's dumped into the current mapping vector, which is eventually passed into the register block, which is dumped into the block component system. So I think that's pretty cool. So how this actually worked with is this used to be a debug module, but now it's the chunk mesh procedure, because chunks are actually procedurally generated, and they're passed into the world, which is a component system. I'm going to have to rename that to the world component system. So let's see, chunk mesh creation. So this is just a bunch of blah, blah, blah optimizations here. Dry runs to pre-calculate a vector. Basically, it's getting if your neighbor is just air, like it's nothing. In the future, that's going to have to probably get if it's air-like, or it's a block box, or it's a liquid as the draw type. It's very complicated, but if you take it step by step, you can break down the problems into bite-sized pieces, and you doesn't all of a sudden it becomes less of a mountain to climb and more of taking a step up a stair. So yeah, this is just doing a bunch of math. It's getting the neighbors, which is the benefit of the component system, because I can just get part of the neighbor, and I don't have to work with the structure completely. So it's less of object-oriented, more data-oriented, which is really nice. And so this is just a quick, these would all be true or false. So this is like, the worst case scenario is the CPU has to run through 6. The best case scenario is just runs through 1. Better than if it has to run through 6 every time using AND clauses. But then it runs through the BCS get mapping. And then this is in the boilerplate code. And so it automatically passes in each index as needed. And so if we scroll all the way up, this is a bunch of calculations for the dry run, which you could see how that works. That's just telling the vector to add so and so. And also my, where is it? Let's see. Oh, whoops, I accidentally pasted. Thought I was getting another GLI error, because for some reason the Rust analyzer cannot understand the glint. It thinks it doesn't exist. I don't know. So face up, we get the atlas, which is the reference to the texture map. So we're basically just borrowing that. We don't change it. And so now we get this as the tuple, and we can automatically assign this data and then put it where it needs to be. I'm going to have to rotate these, because these are actually sideways by default, and that's not good. And that's basically what it does. It just stripes it, which makes it easier for OpenGL to consume, and makes it easier for your graphics card to access all the data in like one strip, one contiguous piece of memory, instead of having to jump around and losing the cache performance. But let's do something else with that, I guess. Let's see. We go to Biome Generator. One thing I find that's cool is we can set this to air, which is always 0. And this does take a second to build, but it's not actually as slow as I thought it would be. For some reason, when I was using Amethyst, like when I my first run with Rust, amethyst projects took a very long time to build. I'm not sure why. You notice that it looks like it's actually broken. But what's happening is it's literally just a strip. I think that's pretty neat. It's just like a plane that's warped with the Perlin noise. And so another cool thing about this, when you do this, you can generate some huge areas. It's actually kind of insane. So if we go back into main, we can set the so it's a middle click that keeps doing this. Oh my goodness. I don't know, you said it's like 40. Also, I want to learn how to dynamically link. You can see this is kind of like crazy. If this had greedy meshing, this would probably be even more efficient. But you can see it running through. And now there's literally absolutely no reason to be playing on this render distance, because this is just like, I mean, you're like this tall. And you'd have to be standing at like the height limit to even be able to see this. But you can, I mean, you can do it if you want. Let's see, if we go back to the Biome Generator, we'll set that to stone. And so this is really why the next step I want to take is set the biome registration in Lua, so I don't have to constantly rebuild the engine when I make biome changes. Another thing I really want to test is somehow implementing the 3D Perlin noise, but I'm going to have to probably use a package from another crate, or a structure from another crate, because this package that I keep saying this package, this crate that I'm using only does 2D Perlin noise, and that's, I mean, it's helpful for this, and it's really fast too. But in all reality, it's not going to be good for caves, like cave generations, where you need 3D heat maps. So yeah, this actually does generate a little bit faster. I think it's pretty neat. And I keep forgetting to full screen it. Sorry about that. I think I've forgotten to full screen it this whole time. But yeah, I mean, that's basically all I got. I mean, it does the thing. And you have it on render distance 10. It's about as fast as it's gonna get. I don't know why you'd be needing 3000 FPS. It's actually making the coils in my graphics card whine, but hey, you can do it if you want. It's up to you. I think that's all I got when I do the biome generation, and probably use a different crate with more Perlin like dimensions, so I can do some interesting stuff like mix Perlin and maybe static. There's a lot of different types of noise. I had one on my mind, but I completely forgot it. I'm actually gonna have to look that up. It was fractal noise, like mixing Perlin noise with fractal noise, and just seeing what kind of caves are carved into the world. I think that would be very cool, actually, but we'll see how it is. It'd be really nice to do some in-depth terrain generation customization in Lua, where specific heat maps are hit. You can like tell to just generate houses or something. I don't know. There's a lot of stuff you can do. It's just how much work do you want to put into it, basically. So anyways, thanks for watching, and sorry this video was so long, and peace out.